On-stream and off-stream inspection guidance for fired heaters and furnaces, effective inspection methods to ensure operational safety. Guidance for inspectors, on-stream and off-stream inspection of fired heaters furnaces, purpose of this presentation, applicable codes and standards, scope of fired heaters and furnaces, major components of fired heaters, on-stream inspection overview, off-stream inspection overview, radiant tube damage mechanisms, non-destructive examination and measurement, refractory and insulation inspection, inspection intervals and planning, documentation and reporting, conclusion and key takeaways. The purpose of this presentation is to provide inspectors with clear, practical, and code-aligned guidance for performing both on-stream and off-stream inspections of fired heaters and furnaces. Fired heaters are complex systems where mechanical integrity, combustion performance, and refractory condition are closely linked, and inspection activities must consider all of these aspects together. This presentation aims to clarify the objectives of each inspection type, explain what can realistically be assessed while the unit is operating, and define the additional examinations that must be carried out during shutdown. Another key purpose is to align inspection practices with the intent of API 510 and API 573. Ensuring that inspections support fitness for service decisions, remaining life assessments, and risk management. The presentation also helps inspectors understand their role within the owner-user inspection program, including documentation, reporting, and communication with operations and engineering. By following the guidance presented, inspectors can improve consistency, detect damage mechanisms earlier, and contribute to safer and more reliable heater operation across the facility lifecycle. The primary codes and standards that form the basis for fired heater inspection activities. API 510 provides requirements and guidance for in-service inspection, repair, alteration, and re-rating of pressure vessels, including heater tubes and headers that fall within its scope. API 573 focuses specifically on the inspection of fired boilers and heaters, offering detailed guidance on inspection methods, damage mechanisms, and safe operating practices unique to fired equipment. ASME Section 1 and Section 8 establish the original design rules, allowable stresses, joint efficiencies, and temperature limits that inspectors must understand when evaluating degradation or determining minimum allowable thickness. Together, these standards define not only what must be inspected, but why certain limits exist and how deterioration affects fitness for service. Inspectors are expected to apply these standards within the owner-user inspection program, using sound engineering judgment while maintaining compliance with regulatory and corporate requirements. The scope of this guidance includes a wide range of fired heaters and furnaces commonly found in process industries. These include process heaters used for heating hydrocarbon streams, crude and vacuum heaters in refineries, steam methane reformers in hydrogen production, and utility or package heaters that support ancillary systems. The guidance applies to various configurations such as vertical cylindrical heaters, box-type heaters, and cabin-style furnaces. While specific designs may vary, the fundamental inspection principles remain the same, focusing on pressure-containing components, high-temperature materials, combustion systems, and refractory linings. By defining a broad scope, the presentation ensures that inspectors can adapt the guidance to different heater types while maintaining consistent inspection logic and code compliance. Understanding the major components of fired heaters is essential for effective inspection. Key components include the firebox or radiant box, where radiant tubes are exposed to high heat flux, the radiant tubes themselves, which are pressure parts subject to creep and oxidation, the convection section, which recovers heat and may experience fouling or corrosion, the burner system, including burners, pilots, and flame arresters, and the stack and ducting that handle flue gases. Refractory and insulation protect the steel casing and influence heat distribution and tube life. Inspectors must be familiar with how these components interact, as deterioration in one area, such as refractory damage, can rapidly accelerate tube overheating and failure. A component-based understanding allows inspections to be systematic and focused on high-risk areas. On-stream inspection refers to inspection activities performed while the fired heater is operating or in hot standby. The primary objective is early detection of abnormal conditions that could indicate developing damage or unsafe operation. On-stream inspections rely heavily on visual observations, operating data, and non-intrusive monitoring techniques such as infrared thermography and tube metal temperature trending. Inspectors must work closely with operations to interpret process conditions and identify deviations from normal behavior. While on-stream inspections cannot replace internal examinations, they are critical for preventing escalation of issues between shutdowns and for identifying areas that require focused attention during off-stream inspection. Off-stream inspection is conducted when the heater is shut down, cooled, isolated, and made safe for entry. This inspection phase allows direct access to internal components and provides the most reliable information on actual material condition. Off-stream inspections include detailed visual examination of radiant tubes, tube supports, burners, and refractory, as well as non-destructive examination such as ultrasonic thickness measurement and metallurgical assessment where required. The objective is to quantify damage, assess remaining life, and verify whether components are fit for continued service. Findings from off-stream inspections form the basis for repair decisions, inspection interval adjustments, and long-term integrity planning. Radiant tubes are among the most critical and vulnerable components in a fired heater. Common damage mechanisms include high-temperature creep, which leads to tube bulging and eventual rupture, oxidation and metal dusting, which cause wall thinning and surface degradation, and localized overheating due to flame impingement or poor heat distribution. Inspectors must be able to recognize visual indicators of these mechanisms, understand the operating conditions that promote them, and relate observed damage to temperature history and material properties. Accurate identification of damage mechanisms is essential for selecting appropriate inspection techniques and for making defensible fitness for service evaluations. Non-destructive examination plays a key role in off-stream fired heater inspection. Ultrasonic thickness measurement is commonly used to assess remaining wall thickness of radiant tubes and headers, while profile scanning can identify localized thinning or bulging. In cases where creep damage is suspected, metallurgical replication and hardness testing may be employed to assess microstructural degradation. Inspectors must ensure that NDE methods are appropriate for high-temperature materials and that measurements are taken at representative and historically consistent locations. Proper data recording and comparison with previous inspections enable reliable trending and remaining life assessment. Inspection intervals for fired heaters should be established based on risk, damage mechanisms, operating severity, and historical performance, consistent with API 573 guidance. Inspectors contribute by providing accurate condition assessments and identifying areas of accelerated degradation. Planning for inspections, particularly off-stream inspections, should begin well before shutdown and include review of previous findings, identification of high-risk areas, and selection of appropriate NDE techniques. Well-planned inspections maximize the value of shutdown time and improve the quality of integrity decisions. Thorough documentation is a fundamental requirement of professional inspection practice. Inspection reports should clearly describe findings, include photographs and measurement data, and identify damage mechanisms and affected components. Reports must also provide clear recommendations, such as continued operation, repair, replacement, or increased monitoring. Consistent documentation supports regulatory compliance, enables effective trending, and facilitates communication between inspection, engineering, and operations. Inspectors should ensure that records are retained and managed in accordance with the owner-user inspection program. In conclusion, effective inspection of fired heaters and furnaces requires a balanced approach that integrates on-stream monitoring with thorough off-stream examination. API 510, API 573, and ASME principles provide a robust framework for understanding design limits, damage mechanisms, and inspection requirements. Inspectors play a critical role in safeguarding personnel, protecting assets, and ensuring reliable operation by applying these standards with sound engineering judgment. Consistent inspection practices, accurate documentation, and close collaboration with operations and engineering are essential to managing the risks associated with high-temperature fired equipment.